Welcome back. Today we're going to be working on scaling fractions and comparing them. So when I'm scaling something, I'm seeing if it grew or if it shrunk, and then I'm going to compare it to the fraction that it gives me. So 3/2 times 2/3 is greater than, less than, or equal to 2/3. So I'm going to come over to the side and I'm going to say 3/2, I have to multiply, then add, because that is how I know how to change a mixed number back into a workable fraction. 3 times 2 is 6, plus 1 is, 7. 7/2 times, again, multiply, then add. 2 times 3 is, right, it's 6. 6 plus 2, it's 8. 8/3, so I get 56/6. Now, I can't leave it that way. I have to change it back. So, how big can I grow 6 before it goes over 56? How big can 6 go? How many 6's fit inside of 56? 9. So that gives me 54, so 9 and 2/6. I can actually simplify that 2/6 down. I can divide it both by 2. So 9 1/3 is greater than, less than, or equal to 2 2/3. 9 1/3 is greater than, less than, or equal to 2 2/3. Chomp. It's greater than. My whole number is bigger. I can't just look at the fraction. I have to look at that whole number too. That whole number is 9. 9 is bigger than 2. Let's look at number 4. 4/5 times 2/3 greater than, less than, or equal to 2/3. So I'm going to come over and I'm going to work it. 4/5 times, I know 2/3 is 8/3 from the previous problem. And I get 32/15. How many 15s fit inside of 32? Think of a clock. 15 minutes. How many 15 minutes will fit inside of 32? It's 2. 15 times 2 is 30. So I have 2 left over. 2/15, 2 and 2/15 is greater than, less than, or equal to 2 and 2/3. Are my whole numbers the same? Yes. I can't look at the whole number for this. 2/15 is greater than, less than, or equal to 2/3. Right. It's less than. 2/15 is closer to 0. 2/3 is closer to 1. You can use your estimation skills there to figure out which way it will go. Let's look at number 5. 4 3/5 greater than, less than, or equal to 4 3/5 times 4/4. So I'm going to bring my 4/4 down. And again, multiply, then add. 4 times 5 is? It's 20. 20 plus 3 You're so right. It's 23. And 23/5. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9, over 20. How many 20s will fit inside of 92? To think about that, I'm going to think of it as counting by 2's. How many 2's will fit inside of 9 without going over? You're right, it's 4. So 4 times 20 is 80. That leaves me 12 left over. Can I simplify 12/20ths? Can I reduce that? I can. What can I reduce it by? 2, 3, 4, or 5? Right, 4. 4 is the biggest number I can reduce it by. I can reduce it by 2, but that gives me one extra step. So I'm going to cut that step out, and I'm going to say I'm going to reduce it by 4. $12 divided by 4 is? Right, 3. 20 divided by 4? Yeah, it's 5. So let's go back to the original problem. 4 3/5 greater than, less than, or equal to 4 3/5. Yeah, they're equal. Let's look at one more problem. We're going to look at number 18. We're going to order these from least to greatest without multiplying them out. Without multiplying them out, I'm going to order them from least to greatest. So let's look at them. 2 times 3/5, 2 1/4 times 3/5, 3/4 times 3/5, 3/5 times 3/5. What do you think my smallest fraction is going to be? 1, 2, 3, or 4? You're right, it's 3. There's no whole number attached to 3/4. So my product is going to be less than my starting fraction. So there's a 1. Which one's going to be the next smallest, the next least? 1, 2, or 4? Right, 4. Because 5/5 tell me 1. Which will come next? 1 or 2? Right, 1. Because you're just multiplying by one whole number. And my greatest is 2 1/4 because you have a whole plus a little bit extra to deal with. So that will make your beginning multiplication problem bigger, which means your product will be bigger than what you're starting with. I hope this has helped, and I'll see you again real soon.